Hello there, wherever you are. This is Mr. Richards, and today's lesson is in similar figures. We're going to quickly discuss what similar figures are and the properties of similar figures. And if we go ahead and define similar figures are figures that have the same shape, but not necessarily the same size. Now, for two figures to be similar, something has to be true about their angles and their sides. First off, the corresponding angles are congruent, or, in other words, have the same angle measure. And when it comes to the corresponding sides, the sides are proportional and are opposite, or have opposite corresponding angles. Now, as we look for the corresponding parts, let's first look now at two shapes. I have this triangle here, and then another triangle here. I am going to call this triangle A, B, C, and this triangle X, Y, Z. We're going to say that ABC is similar to X, Y, Z. And the way we can write that in notation is triangle ABC is similar to triangle X, Y, Z. Now, the corresponding angles here, as I draw these in, that means that angle A is congruent with equal sign with a little squiggly to angle X. And then if I put two lines here with B and two little lines or arcs there with Y, that's saying, okay, angle B is congruent to angle Y. And then lastly, if I put three of these with Z and three of those with C, angle C would then be congruent to angle Z. And as for the corresponding sides, side AB is going to correspond with XY. BC is going to correspond with YZ. And we'll call it AC is going to correspond with XZ. The figures are similar in our example, and we want to find each missing measure. Well, we're given a 12 and a 33 with ABCD, and a 3 and an X here with MNOP. So, 3 and X, 12 and 33, and we're looking to find our X. We can actually set up a proportion to solve this question. We're going to look at it and say, all right, MO is going to equal AC. Notice how MO and AC are corresponding sides. And we're going to set that equal now to the other side we're looking for here, OP on top, and then CD on the bottom. Now notice, as I set up this proportion, I started with that MO, and on the bottom, the matching side, AC. On this other side here, this other ratio, OP is on top because it's in the same shape as MO. And then the matching side to OP is CD. Well, now I can fill my numbers in. MO is 3 over AC is 12, and that's going to equal OP is X, and CD is 33. Well, we can solve proportions by using cross products. So 3 times 33 is going to equal 12 times X. 3 times 33 is 99, equals 12X. We want to solve for X, so divide by 12 on both sides. And 99 divided by 12 is 8, and 25 hundredths equals X. The figures here are similar, and find each measure. Well, just because you're not given sides doesn't mean you can't label the sides, and it sometimes is easier to label them and saying, okay, this shape with the 3 angles, I'm going to call that A, that corner. The one with the 4 is going to be B, and then let's go around C and D. And then, let's go with E, F, G, and H. Sometimes it's easier as we're setting up our problems to know exactly what we're dealing with. Well, one of the sides I do know on the shape on top is AB. So I'm going to say, all right, that AB. And on the bottom of that is going to be the side in the other shape that matches. So AB has the 3 arcs and the 4 arcs. The other one in the other shape with the 3 arcs and the 4 arcs is EF. And that's going to be equal to, well, we're looking for eventually FG. So we'll write FG on the bottom here, because again, we do want our shapes to match on either top or bottom. And then the one that matches FG in the other shape is BC. And now we can make our substitutions in order to solve our proportion. AB is 10, EF is 5, and that's going to equal BC is 24 over FG is X. And again, notice, as we set this up, on top, they're in the same shape. On the bottom, it's the other shape. But in each individual ratio, the 10 matches the 5, and the 24 matches the X. Now we can cross multiply to solve. We have 10 times X, and that's going to equal 24 times 5. 10X is going to equal 120, since 24 times 5 is 120. Divide by 10 on both sides to get our X alone, and X is going to equal 12. Nested boxes are a series of boxes that fit inside one another. The faces of the boxes are similar rectangles. A face in the larger box has a length of 24 centimeters and a width of 13.5 centimeters. If the width of a face on a smaller box is 9 centimeters, what is the length of the smaller box? Let's go ahead and draw these boxes first so we can see what we're dealing with. Now, you know I'm not a perfect drawer here. I'll come as close as I can to drawing 2 rectangles that are similar to each other inside each other. Well, the face of the larger box has a length of 24. So this side is 24. And a width of 13.5. Then, if the width of the face is 9 centimeters, okay, we had width at 13.5. The width is 9 centimeters on the smaller one, so this side is the 9 centimeter side. What is the length of the smaller box? So we're looking then for this side. And we have 2 methods to solve this. The first method is to write and solve a proportion. If we call this missing side X, and we could start our proportion by writing X over the matching side in the larger box of 24 equals 9 over 13.5. And remember, the x and 9 are in the same shape, so they're on top, and the x and 24 are the matching sides. If we cross multiply and solve this, we get 13.5x equals 24 times 9. And 13.5x will equal 216. And when you divide by the 13.5 on both sides, 216 divided by 13.5 is 16. So x equals 16 centimeters. And that's certainly one way that you can solve the problem. Now let's solve this a second way, and that's called what's called using the scale factor. Now if we look at the widths, we know the width of the larger one is 13.5. And we know the width of the smaller one is 9. So if we'd simplify this, 13.5 divided by 9, we get 1.5. This means we have a scale factor of 1.5. So we can write an equation then that says the 1.5 times that missing side x should equal that longer side of 24. So we're using the scale factor 1.5 times our missing side x equaling the larger side of 24. Well, how do we solve for x? Divide by 1.5 on both sides. And x is going to equal 24 divided by 1.5, which just happens to be, again, 16 centimeters. That's it. Good luck.